In this slide, we'll focus on the topic of APIs and their role in facilitating application integration. We will first introduce APIs and then look at the overall life cycle of APIs and how organizations manage and control their use. An API, or an application programming interface, enables one piece of software to communicate with another software. So APIs enable access of data or other services from other systems and enable integration of the overall application or system. The request could be in terms of requesting more data, exchange of information between applications, etc. APIs basically abstract the backend complexities from users requesting the backend services. So users simply make a call requesting a service or data and they get the results. APIs therefore are great to expose one's services to the outside world. For example, as we had covered this earlier, a travel website can expose its data about hotels and airlines and reservations to requesting users. In fact, most web applications have APIs in action behind the scenes, where they are requesting data from various internal and external applications and systems. So when used in this manner, where organizations open up the data and services for others to use, organizations can use APIs to monetize their services. It's a way where organizations can make the product, services, and data accessible to others and increase their revenue. So in the example of an online booking company that specializes in providing inventory information of various hotel rooms, etc., it can sell access to its data and services by exposing its APIs to other organizations and online sites who may want to build an online portal of their own for hotel and airline reservations for its customers. The use of APIs thus provides that data on bookings and other related services. So this opportunity to monetize one's services and data enables organizations to rethink their business models and accordingly package their data and services to make them easily accessible to others. With the increasing importance of APIs, a number of API management and lifecycle frameworks and products are now available. We will cover them a little later. Some examples of APIs and API-related technologies include SOAP, XML, JSON, and REST. REST, for example, stands for Representational State Transfer. It's no surprise, therefore, that the discussion of APIs is no longer limited to the technical circles, but it's also becoming an important part of an organization's digital and application integration strategy and is actively discussed by top management of the organizations. This digital strategy guides how to integrate various web and digital services into full functioning digital applications. We should recognize that the process of developing, publishing, and consuming APIs is complex and accordingly has a life cycle of its own and must be managed as such. Let's review some of the key steps and phases of this overall life cycle and also review this illustration to help us understand this life cycle. Taking a high-level view of this picture, we see API providers, which provide the APIs. We also see the API consumers who use or consume those APIs. And here we see the backend services, which the APIs access to get the relevant data and services and return it to the requesting API consumers. So if you look at the overall life cycle, one of the steps is developing and test APIs. In terms of the overall API lifecycle, this step involves the development of the APIs by API providers who wish to make their APIs available to others. This process requires the API providers to interact with an API portal, which essentially provides an ecosystem for developers where they can develop and publish APIs for eventual consumption by other consumers. The API development portal also has all the necessary tools for developers to develop, test, and publish their APIs. Once APIs are developed by the API providers, they are published and distributed to runtime environments through the development portal. And this is where API consumers can access those APIs. As part of this process, developers also document and provide information on how their APIs work and how they should be accessed and used. The third important step of API lifecycle management is that of API runtime management. Once APIs are published in a production environment, there are various aspects to managing that environment and the overall process, which involves directing the usage of APIs by various API consumers, monitoring the usage of APIs, security management, and so on. This function is normally facilitated by an API gateway, which we will cover in more detail in the next slide. Once APIs are published, the API gateway manages their overall consumption by ensuring security and keeping track of how they are used, maintaining the right metrics, etc. The key components of API runtime management include the following. Consume APIs. Once APIs are made available in the runtime environment, API consumers can discover and consume those APIs. The second step is the monitoring of usage. As we will see later, sophisticated API gateway solutions provide a lot of functions where usage of those APIs are monitored. API gateways also help in monetizing of APIs. So they provide functionality where they can track usage and consumption of APIs, which can then help organizations in monetizing them through the full lifecycle management of reporting the APIs, invoicing the consumer of those APIs, collecting revenues on those APIs, and so on. And finally, there is the analytics and insights. With the full API lifecycle and management functions in place, this necessitates a lot of analytics functions and collecting of insights. To continue the earlier discussion, let's review the characteristics of an API gateway in more detail. An API gateway is the centralized portal that connects API consumers to backend services. It serves as the front door to connect applications, users, IoT devices, etc. to backend services and to various types of data. It also enables secure and authenticated connectivity to backend distributed applications. For example, it can authenticate API consumers to ensure that they are authorized to request those services. So all those security functions are provided by the API gateway. An API gateway helps in standardizing and unifying service access methods. With numerous types of application services in the background trying to access backend services using different methods, an API gateway can provide a standardized method to access the backend services. Also, as we described earlier, that not having such a gateway can result in numerous connections between API consumers and backend services, as we can see here. An API gateway can help reduce the traffic between consumers and services because it can reduce the point-to-point connections between consumers and backend services. The reduction in traffic between consumers and services helps in the improvement of latency for client applications and thus the overall performance of the applications. An API gateway also shields the services from unauthorized access and even attempts of access, else services would be exposed and susceptible to repeated distributed attacks from the internet, DDoS attacks. The gateway acts as that filter and acts as a firewall installed in front of those services. An API gateway also limits API access. This is applicable in the case of monetization of backend data and services, where organizations may want to implement some type of metering to track API access and may want to limit access to backend services based on the specific subscription services. With different API standards out there, an API gateway can support different types of API technologies and protocols. These include supporting RESTful or WebSocket APIs. Now, WebSocket APIs are stateful, where they enable maintaining a persistent connection between 2 points where both ends are aware of the state of the connection, thus facilitating real-time communications. REST, on the other hand, is a stateless protocol where the clients and servers don't know about each other. As APIs play a very important role in the architecture and design of digital and cloud-based applications, a number of products and services have come to the market over the past few years where they provide complete lifecycle management services. Here are some of them. Google Apigee, AWS. AWS provides API management solutions for its AWS services. MuleSoft company has a very popular API lifecycle management solutions. Amplify, Software AG Kong, Microsoft has its own API management solutions, and so on.